Hello everyone. In this video we are going to do some examples from worksheet 1 and worksheet 2. So this is our worksheet 1. So I'm going to do the first problem, like problem number 6, okay, from worksheet 1. So using the equation and the diagram below, identify what is the limiting reagent. Right, so you are given this equation. So first step is you have to check whether the given equation is balanced or not. So this one looks like it's balanced, right? So I'm going to do our have versus need table. Right, so we have two things, mg and o, right? Now what is our given? So we have to count the particles. So these are the atoms, right? So 1, 2, 3, 4, 5. We have 5 moles of magnesium. And we have 1, 2, 3, 4 moles of oxygen. Right? So first of all, I have to figure out how much of the given one, how much of the other do I need, right? So I'm going to pick moles of magnesium and see how much of the oxygen do I need, right? So if I start with 5 moles of magnesium and I have to use up all the 5 moles of magnesium, how much oxygen do I need? Okay, so how do I figure out? I have to use the mole ratios. Now what is the mole ratio of magnesium and oxygen? 1 mole magnesium is equal to 1 mole oxygen, right? So this is the mole ratio or the conversion factor that I'm going to use. So when I start with 5 moles of magnesium, how much oxygen do I need? So the mole ratio is 1:1. So 1 mole magnesium equals 1 mole O2, O, right? You can see this cancels out and you get your answer in moles of oxygen. So 5 times 1 is 5. So now you compare the have to need. So we have 4 moles of oxygen, but we need 5 moles of oxygen. So we need more than what we have. So 5 is greater than 4. So this means have is less. That makes oxygen as your limiting reagent. So limiting reagent is oxygen. Okay. And then let's do this one. In this one we have a different ratio. So again, set up your have versus need table. So we have versus need, and then we have here we have Na, and here we have sulfur. So let's count how many moles of sodium atoms do we have? 1, 2, 3, 4, 5, 6. So we have 6 moles of sodium. And how many sulfurs? 1, 2, 3, 4. We have 4 moles of sulfur, right? So pick one, and again I'm gonna pick sodium and see how much of sulfur do I need, right? So if you start with 6 moles of sodium, how much sulfur do you have? What's the mole ratio of sodium to sulfur? Sodium is 2 moles sodium to 1 mole sulfur. So 1 mole sulfur goes here and 2 moles sodium goes here. Sodium and sodium cancel, you get your answer in sulfur. So 6 divided by 2 is 3 moles sulfur, right? So this number here is 3. Now compare the amount that we have to what we actually need. We have 4 moles of sulfur, but we only need 3 moles of sulfur. So we have more than enough. We are not going to run out of sulfur. So that means sulfur is our excess reagent. Since we have more than what we need, we only need 3 moles, but we have 4 moles. So sulfur is your access reagent. That means sodium will be our limiting reagent. So sodium will be our limiting reagent. Okay. So this is how we analyze the diagrams. Okay. Now let's do some problems from worksheet number 2. So this is our first problem. I have noted that problem down on a paper. So this is worksheet 2, problem number 1, right? So this is already balanced for you. Make sure that before you start the problem, you have to check whether the given equation is balanced or not. If not, you have to balance this equation. But if it's already balanced, then you can start. And sometimes some questions will ask you to write down the balanced chemical equation first before you can attempt the problem. Okay. So I already have noted down this problem here from worksheet 2, problem number 1. So we have 14.8 grams of C3H8 and we have 3.44 grams of O2. They react together and this is the balanced equation. So first step is find the limiting reagent and the access reagent, right? So I already have calculated the molar masses of all the things that we need for this question. We need the molar mass of C3H8, we need the molar mass of oxygen, and we need the molar mass of water. Okay, so you can calculate those and then we can start the problem. Okay, so first step is find the limiting reagent and the access reagent. For that, we need to set up our have versus need table. Remember, have versus need table should always have moles in it. So the two things that we need are O2 and C3H8. Okay. So let's write down the have. And you can assume that this is all in moles, right? So I would not be writing moles. Okay, have versus need. Okay. So now, since we are given 14.8 grams of this, convert that to moles first. And then we are going to convert 3.44 grams of O2 to moles. So this is always our first step. Always convert the grams to moles and then we can put that as have in our have versus need table. So you start with 14.8 grams of C3H8 and convert that into moles. I already calculated the molar mass of C3H8, which is 44.1 grams, and this is equal to 1 mole. So grams cancel out with grams and you get moles of C3H8, which is equal to 0.336. So moles C3H8. So I'm going to put that number here, 0.336 moles. Similarly, convert 3.44 grams of oxygen to moles using its molar mass. So that would be 3.44 grams O2. Remember, O2 is a diatomic, so 32 grams O2, and that is equal to 1 mole of O2. So if you solve, you will get 0.108 mole O2. So I'm going to put that number here. So let's write 0.108, okay, moles of O2. Now these are all moles. Now I am going to pick one number. You can pick this or that, does not really matter, but I have a habit of picking the first one first, right? So starting with 0.336 moles of C3H8, you will figure out how much oxygen, how many moles of oxygen do you actually need, right? So how do we calculate? So this is your A, you're solving for B, going from moles of A to moles of B using mole ratio, right? So if I have to start with 0.336 mole C3H8 and then solve for the moles of oxygen, what's the mole ratio? Mole ratio is 1 to 5. So 5 mole O2 is equal to 1 mole C3H8, right? So you can see moles of C3H8 cancel and you get your answer in moles of O2. If you solve, you will get 1.68 moles of O2, right? So I'm going to put that number here. We have 1.68 moles of O2. So this is the amount that we actually need. Now look, we have only 0.0108 moles of oxygen. Now compare these two numbers. Which one is more? So we need more oxygen. We need 1.68, but we have only 0.108, right? So our have is less. So that means oxygen is our limiting reagent. So our limiting reagent is oxygen. Why? Because we have less, right? So we have only 0.1 and we need 1.68. So this amount is less. We're going to run out of oxygen before we can use up all the C3H8, right? So limiting reagent is our oxygen. That makes C3H8 as our access reagent. So access reagent is C3H8. Okay. So first step is done. The first part was find the limiting reagent and access reagent, and we already calculated that. Next is determine the grams of H2O produced. Now always remember, limiting reagent will decide how much product is produced, right? So only limiting reagent will decide how much product will be used. So this is your A. Limiting reagent is your A value that you start with. So you are going to go from moles of A to moles of B to grams of B. Now this time moles of A is your limiting reagent. We already calculated the moles of A, didn't we? Right? So since oxygen is our limiting reagent and we already calculated how many moles of oxygen do we have, right? So let's write down. We have 0.108 moles of oxygen and convert that into moles of water. Determine how many grams of water is produced, right? So what is the mole ratio of water to oxygen? It's 4 moles water to 5 moles oxygen. So I'm going to write it there. 4 moles water equals 5 moles oxygen, right? But since we need the grams, convert the moles of water to grams. So 1 mole water is equal to how many grams of water? The molar mass of water is 18.02 grams water, right? So you can see moles cancel with moles, moles of water with 1 mole of water, and you get grams of water, right? So if you solve that, this will give you 1.555 grams of water. So this much water will be produced, and always remember we will start with the limiting reagent. Now the third part of the problem is determine the grams of excess reagent left over. For this, let's come back to our have versus need table. So this was our have versus need table. So in order to calculate how much of the excess reagent was left over, since C3H8 is our excess reagent, first we will figure out how much of the excess reagent was actually used up by 0.108 moles of oxygen. So we will start with oxygen and see how much of the C3H8 will be used up by 0.108 moles of oxygen, right? So now oxygen is our A and we are solving for B right here, right? So you start with 0.108 moles of oxygen and see how many moles of C3H8 is required, right? So what is the mole ratio between oxygen and this? So 1 to 5, right? So 5, I'm going to write 5 moles O2 equals 1 mole C3H8. You can see this cancels with this, you get your answer in that, right? If you divide this by 5, so you will get 0.0216 mole C3H8. So I'm going to put that number here. So that would be 0.0216. So we only used up this much of C3H8 and we had a lot of it, right? Now how do we calculate how much of C3H8 will be left over? You simply subtract these two numbers, right? So let's calculate how much of C3H8 will be left over. So C3H8 left over equals 0.336 minus 0.0216, and the answer should be in moles, right? So this comes out to be 0.3144 moles C3H8, right? Now since we need grams of the leftover, I am going to convert this into grams now, right? So convert 0.3144 moles of C3H8 into grams. 1 mole C3H8 equals the molar mass of C3H8 is 44.1 grams. Moles cancel out with moles, you get your answer in grams. If you solve, you will get 13.87 grams of C3H8 will be left over. Right? So this is how we solve the limiting stoichiometric problem using have versus need table. In my next video, I'm going to do another problem probably problem number 2.